So here's our steam conglomerate. This is just probably the uppermost unit of it. Got to do a couple little measurements here. Just get a ruler out so you get some sense of the size of the cobbles. You can see we have a matrix-supported conglomerate here. There's yes, a lot of large cobbles here. Some are over 6 or 8 inches in diameter here. They look pretty well rounded. And you can see that they are extremely poorly sorted. So, what we have here is also the law of inclusions. So ask yourself, are these cobbles older than the deposit they now form a part of, or younger than the deposit they now form a part of? Clearly, these cobbles are older. Clearly, these cobbles are older. So, we can now start to think about the story of how these cobbles got here, where they eroded from, and the environment they're laid down in. We talked a little bit about the contact, about how we have a conformable contact and how this is probably a river delta deposit. Now we know a little bit more about the river from these cobbles. I'm going to take a look at a couple individual ones that really showcase some of this. This is a classic clast known as a Poway clast. Hopefully you can spot the little squares of white mineral. That white mineral is plagioclase feldspar. The reddish color is derived from some potassium feldspar, orthoclase. And there's quite a bit of quartz in here, though the quartz in here is so transparent you don't really spot it, especially on a piece as dusty and dirty as this one here. But if you looked at this under magnification, you would see a lot of transparent minerals in here. I guarantee you I've done it. So this cobble and its shape tell us a lot about the history and the fact that there's a bunch of cobbles that look like this here. So this cobble's a rhyolite. So what is it? Quartz, K-spar, and some plagioclase as a porphyry in it. Invariably tells you that you have rhyolite. If it's a fine-grained aphonetic rock, is that what it is? We've even looked at this in previous labs. So, we do have rhyolites in San Diego County, but none of them are this red or have these little crystals in them. They are all plagioclase crystals in them. They are, in fact, the nearest place we find a rhyolite that is older than this deposit is northwest Sonora, Mexico. In essence, there had to be a river between here and northwestern Sonora that, at the time this deposit was laid down. And on one level, this is hard to imagine. We now have very tall mountains between here and there. We're also quite a bit north, but hopefully most of you have heard of something called the San Andreas Fault, which has been carrying us northward since about the late Miocene. Yeah. So we've actually drifted a little further away. Most of the mountain ranges in San Diego County underwent pulses of uplift since the Eocene, so it is also logical that there may not have been mountains back then. There certainly was no Gulf of California back then. The oldest seafloor in the Gulf of California is about 23 million years ago, and the oldest seafloor that's near our end of the Gulf of California is quite a bit younger than that. So, but we know there had to have been a big river here because these are all very well-rounded cobbles. This means they got tumbled quite a bit. They're also very poorly sorted. telling us that this river underwent, and clearly the areas are fairly large, so it took quite a current. So the size tells us we had quite a current. The sorting tells us that the current was highly variable. This area experienced frequent floods and protracted dry spells. And the rounding tells us that this was a very long river. Now we have a second piece of evidence to support the protracted dry spells, and that again is this caliche soil. I talked about how you need a climate that is a little warmer and a bit wetter than San Diego to get a caliche calcite-rich soil. It also, in order to get a caliche soil, you also need a climate that not only does it get more rain, but it also has long protracted dry spells. And yes, South Texas has that right now. So that just some things for food for thought on this. And so what we've got here is the law of inclusions. Even cooler, you can actually see inclusions within inclusions. Let's see if we can spot anything else here that's exciting. Intriguingly enough, I'm noticing a lot more local granites and other things right here. There are places where this river probably did cut a gap through other mountain ranges. So I'm guessing we're seeing some pieces of that. But these little crystals within the rhyolite are examples of inclusions within inclusions. And they clearly crystallized before the rest of the rhyolite. You can also see this rock's got sort of a lot of pits on its surface. This is a place where chemical weathering has attacked most of the plagioclase, because the plagioclase is much more susceptible to chemical weathering than everything else around it. So that's my food for thought right now on all this. We're going to head over to another geologic deposit and see if we can maybe tease out the layer beneath this, or at least and look at some of the stuff above this as well. We're also going to see if we can find some of those Cretaceous-aged rocks. And here we are. Above us is the Pomerado conglomerate. Below us is the Mission Valley. And as we go up, you can see that, yeah, we are back into a higher energy depositional environment. Back, the river has returned, and it looks a little different up here. Hopefully we're able to spot some of these differences as we walk up through the Pomerado Formation up here. Hopefully you've figured out which of these three formations is the oldest and youngest by law of superposition. Younger stuff's on top, meaning we are moving forward in time. There you go. Oh, here's some layers, yeah. Notice the cobbles, there's actually a bit more well-defined, oh, that's a root, but there's more well-defined layering in this one than the stadium. Not if you have layers of not exactly uniform sizes. This is still poorly sorted, but the layering is more apparent. There's like more, you look like you're seeing individual events within this river on some of these layers of bigger rocks, and these act as little steps going up this hill. You also notice a lot more rhyolite in the cobbles. It's as if the source region has evolved somewhat during the hiatus in which the Mission Valley Formation was laid down. Lots and lots of these porphyritic textures. I'm also seeing some quartzites, but yep. And some other stuff. There's some more of that layering up there. Yeah. And so was this that the river got even more variable and flooded even more largely. We're sort of looking at here the evolution of a river basin, which I think is pretty darn awesome. All right.